with pencil you write how many sticks are there. Okay, if there are 4 questions, you just write 4. So it is a reminder for you that you need to answer for 4 questions so that you don't lose marks. Hope you are getting what I'm saying. Okay. Now moving back to what we are discussing. You know this chapter. You have something to tell me? No. Okay. So in this chapter, we have only little bit left out, and I told you the most important part is dipole as far as exam is concerned. So in dipole itself, we have something more to learn. We have learned what is the electric field. See, please, when you talk about dipole, you know there are two charges, and those two charges we always take with the distance, and the two charges are equal in magnitude but opposite in direction. And there is a small distance between them, and we always think that equal and opposite charge. So there won't be any electric field near it because one is positive, other is negative. They are equal in magnitude. But now you understood that electric field surrounding a dipole is not zero. Okay, it differs on the equatorial line. It has a value minus kp by rq. On the axial line, it has a value 2 kp by rq. So it's clear from the expression that the electric field on the axial line is twice than that of the equatorial line. And as you move away from the dipole, the electric field is decreasing more rapidly. That is, please, all of you, please mute your mic. Only when I ask you, please to unmute, okay? So as you move away from the charge, if there is a single charge, as you move away from it, you learn the expression for electric field as kq by r square. It decreases at the rate of 1 by r square only. But if there are two charges, it decreases at the rate of 1 by r cube. This is a major difference between a single charge and a dipole. Now, what more we want to know about dipole is that we have learned two situations, axial line and equatorial line. Please keep in mind on axial line we got it as 2 kp by r cube. It is in the direction of dipole moment, whereas on the equatorial line it is minus kp by r cube, and it is opposite. This minus sign has a very important role there. E is in the opposite direction of electric field. So you are getting E equivalent as minus kp by r cube. Now, while deriving this, I hope you remember how we got it on the equatorial line. We have taken two charges. Okay, we have taken a point here, and we got the value, and we have taken the center line, the distance from the center as r. We have a minus q charge here. We have a plus q charge here. We have taken this distance as r. Okay, and this distance, you know, the total distance is 2a, and we got the electric field here. We have calculated like this because this is a field at the point due to this one, and field at this point due to this one. We have taken like this, okay, and we got the resultant as like this, and we said this is the total electric field on the equatorial line. We have summed up and we got it as minus kp by r cube. So these are the two cases we have learned, and what more we want to learn today about dipole is that what happens to a dipole, okay, when it is kept in an external electric field. Now, if you listen, what is the meaning of external electric field? If imagine I have created an electric field in this classroom. How can I create an electric field in the classroom? Let me take a positively charged plate and I keep it on the right side wall, and this side I kept a negative charged sheet. Imagine I'm keeping two sheets like this. One is plus, other is negative. One sheet I get positive charge, other sheet I get negative charge. So obviously there is an electric field. We know it is always directed from positive to negative. So this is how I can create an electric field. So there is an electric field between this. There are different methods of creating electric field. Okay. In the coming chapters, you learn different common methods of creating electric field. So this is how you can create an electric field. So imagine I have created an electric field in the classroom. And whatever be the method I follow, that doesn't matter. The thing is there is electric field in the classroom. Now I am bringing my dipole. By dipole I mean two charges equal and opposite. I have it with me. I am bringing that dipole into this classroom. So I can say that a dipole. Now there is a dipole. Where is it kept? It's not kept in a region where no electric field. It is kept in an electric field. So I'm calling it dipole kept in an external electric field. What is the importance of the term external? This electric field is not created by this dipole. I've already created dipole here. Sorry, the electric field in the classroom. There, I'm bringing another dipole. So I'm calling it a dipole kept in a uniform electric field. Now, there's a term I'm adding here, uniform electric field. What's the meaning of uniform? Okay, it is an external uniform electric field. So this is what we are, what happens. This is the situation we are going to see now. Uniform electric, what's the meaning of uniform electric field? Uniform electric field is a field where electric field is same. Electric field is a vector quantity. So both the direction and magnitude must be same throughout. So in the classroom, if I take any point in the classroom, if I measure the electric field, it must be same. It should act in the same direction, its value must be same. Now, for every question when I deal with, I have to draw a diagram. So how to represent a uniform electric field? In the previous class, you learned that how to represent a electric field surrounding a positive charge. Okay, you all know you have to draw a line without any break, and you put arrow mark away from it, and we say that this is a positive charge. This is an isolated positive charge, meaning there is only this charge here, no other charges in the surrounding region. Now, if you have a negative charge, we draw the other way. The the arrow is towards it because electric field is towards the charge. This is the case of electric field of a negative charge, positive charge and negative charge. Now, if you keep them together, we learn that suppose you are bringing one closer to the other one, there will be changes in the electric field lines. You learned that this is positive and this is negative. We found that electric fields are in this pattern. They change their comparing to the case where they are. Again, right? All these are trying to. So this is the case when they are kept close to each other. Now, when you take this is almost equivalent to the case if the magnitude is same, we know this is the case of a dipole. So when I take a case of a dipole, we learn that the electric field somewhere here. Our electric field on the equatorial line, if I take an electric field on the equatorial line, axial line, I take, you learn that this value and this value are not same. So dipole is not creating a uniform electric field. Electric field at different points are different. So I'm not talking about such electric fields are called non-uniform electric field. Now I need a uniform electric field. So in a uniform electric field at every point will be equal and same in magnitude and direction. So how do we represent a uniform electric field? So listen, this indicates what I'm drawing right now indicates a uniform electric field. While drawing uniform electric field, you have to be careful that the lines that you are drawing must be parallel, not only parallel. This indicates uniform electric field. They are parallel and equidistant. So how do you represent a uniform electric field? Parallel lines and equidistant. See, if one of you draw parallel lines like this and say that this is uniform, this is not a uniform electric field. Because you look at here. You learned as one of the properties of electric field lines as if field lines are dense, okay? Electric field intensity, magnitude will be high. So if you consider point here and point here, you see point A and point B. Here electric field lines are close to each other, more dense. So electric field here is greater than electric field here, because you see here electric field lines are less dense. So this is not a uniform electric field, because here E1 is greater than E2. So this is not what I'm talking about. We are talking about a uniform electric field. So while drawing, you have to be careful. You don't have to measure the distance between them and draw, but it should look like equal distance. Now, this is a uniform electric field, and now here I'm going to take a dipole and keep it in the uniform electric field. So let me bring a dipole. You know, dipole as a minus charge and a plus charge. This is a dipole. Such a dipole I'm keeping in a uniform electric field. And usually we use a line to represent the distance between them. So this is the dipole. And I need to mark, okay, whenever you do it, you have to mark this is minus Q charge and this is our plus Q charge. And wherever you write or you draw a dipole, its dipole moment has to be written. Okay, because you know that is its identity. So I need to mark its dipole moment. We know small letter P indicates dipole moment. And what is its direction? It's always from negative to positive. So its direction is like this. This is the direction of dipole moment. And this is the direction of electric field. So obviously it's very clear from the picture that I kept dipole not parallel to the electric field or not perpendicular to the electric field. I just kept it at certain angle. Okay, that the angle at which I kept this dipole. Okay, I want to mark that angle. Imagine I kept it at an angle theta with the electric field. This is how I kept it in the uniform electric field. Now the question is, if I keep a dipole in an external electric field, what happens to the dipole? Will it stay there like this, or will there be any interaction between the electric field created by this and the existing external electric field? So the question is, what happens to a dipole kept in an external uniform electric field? So let us see what happens to this. We want to know what is the force on the dipole. We learned in the previous class, force or electric field E we defined as F by Q. What's the meaning of this? When you keep a charge Q in an electric field E, it experiences a force F. So if you want to calculate the electric field at a point, you take a charge Q and find what is the force it experiences, and you get the electric field intensity E is equal to F by Q. So here I can also rewrite this as what is F? The force on the charge Q is Q multiplied by E. From this expression I have written this. This we have already learned. So what is the force on a charge which is kept in an electric field? A force on a charge which is kept in an electric field E is Q times E. If you keep 1 coulomb of charge, it will be 1 coulomb multiplied by the electric field. If you keep 2 coulomb, it will be 2 into E. So as you increase the value of the charge, you can see the force of the charge also increases. Now, what we have done, we have taken a dipole. You know, it's a minus Q charge. A minus Q charge is kept in an electric field E. So obviously this minus Q charge will experience a force. So what is the force on this minus Q charge? Force on the minus Q charge is minus Q multiplied by E. Similarly, force on this plus Q charge, it is plus Q multiplied by Q. So Q into E and minus Q into. So this is the force on this charge. So this is our negative charge and this is our positive charge. Now you look at here, what is the direction of this force? What will be the direction of this force? F is in the direction of minus QE. Q is a scalar quantity. E is electric field. So F is minus E, meaning force is in the direction opposite to the electric field. So this experiences a force in this direction And how is this? F is equal to Q into E, meaning F is acting in this direction. You know, the magnitude of this F and this F are same. Let me call this as 1 and this as 2. You can see F1 and F2 are equal in magnitude but opposite in direction. So, what's the conclusion? We can write that. The force, the net force, meaning the total force, the net force on the dipole, the combination of two charges, net force on the dipole is F1 plus F2. What is F1 plus F2? QE plus minus QE, which is equal to 0. Are you getting me, children? Are you all with me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
You know why I keep asking children? I keep asking you to switch on the video and keep calling your names, not to ask some questions and expecting that you give me the correct answer for this. Please try to understand that teachers are asking you to switch on the video in order to have an interaction between us, in order to see if you all keep your video off and if I continuously monotonously talk, I won't even register who else they all are there in my class. Okay. So to get, since the situation is like that, somehow we have to have a rapport. I would like to know each and every one of you so that I want to know you. Every teacher wants to know each of you. And please don't take it that teacher is asking you to switch on the video to ask questions. Teachers will ask you to on the video to ask questions also. And I repeatedly am telling, if you give a right answer or wrong answer, there is no issue in that, because you know that you can, if you have to study, okay? Only when a teacher asks you to study and come, you study, you know. And if there is a test, definitely you will study. So keeping test or asking questions are not to trouble you. It is to help you. And whenever we ask you to switch on the video, I know some of you are not switching on the video thinking that, okay, we will catch you, we'll ask you questions. Okay? Now, I hope you understood what I be trying to tell you. Okay? Can anyone tell me what I be discussing in your own words? Aditya Rajan. Please unmute.
Yes, ma'am.
Please tell me in one sentence what I was trying to tell you.
I'm torque experienced by the dipole.
Aditya, you learned about torque and all in advance, very good, but I didn't use the term torque at all.
No, ma'am.
I didn't reach there. In fact, I didn't reach there.
And the dipole is aligned like that, so I thought you were going to discuss about that.
I'm going to discuss. But my question is, what did I tell you now?
The dipole will align.
No, what did I tell you? What did I write on the board right now? The last sentence. What I wrote on the board. Something about force. Vinayak,
Yes, ma'am.
what did I write at the end? Last.
Oh, the total force experienced by the dipole is 0.
Second, see that this is what you all have to remember. The net force experienced by a dipole kept in a uniform electric field is 0. This is what you get 1 mark question or sometimes 2 mark questions, where you are asked to prove that a dipole kept in a uniform electric field experiences no force. No force means net force is 0. Okay. Now look at this, what we were trying to, we got this. So these two lines must be their answer. You don't have to see in the diagram, clearly you have written minus QE plus QE. So we know that when you say one line is enough. If this diagram is not clearly level, you have to write it down. So this is the importance of diagram. Diagram, everything is there, F1, F2, everything is shown, and we know F1 and F2 are equal and opposite, so you are getting it as 0. So this is the important sentence you have to register. The net force on a dipole kept in a uniform electric field is 0. Why I am keep stressing uniform? Imagine that electric field is not uniform. Let me have a electric field like this. You know this electric field is not a uniform electric field. Here, electric field E1 and here electric field E2. Very clear that E1 is greater than E2. You can see field lines are denser, it's far apart. So E1 is greater than E2. Imagine I'm keeping a dipole here. I'm taking a dipole and keeping it in like this. Here is my minus Q charge and here is your plus Q charge. So what is the force? This is known as a non-uniform electric field. And now what is the force acting on this one? It is minus QE1. At this point it is E1, here it is E2. So here it is QE2. You know QE1, if I add the total force, if I find the total force, QE2 minus QE1. Okay, I add, these are not equal, so it won't cancel. I don't get an answer 0. So in a non-uniform electric field, the net force is not 0. In a uniform, we are talking about uniform electric field. So that's the importance of the word uniform. Uniform electric field, net force is 0. Now, one more thing connected with this. Instead of asking, show that the total force experienced by a dipole in a uniform electric field is 0, they can frame the question like this. Show that a dipole will not undergo a translatory motion in a uniform electric field. What do you mean by translatory motion? So imagine I'm standing here. Okay, if one of you, there are two children standing, one in front of me and the other behind me. Imagine both of them pull me with equal forces towards them. I will not move. You know that, right? She's pulling to that side and she's also pulling, another girl is pulling to this side with equal force. So what happens to me? I stay still. There is no translatory motion as far as I'm concerned. So that is happening in the case of dipole here. This dipole is experiencing equal and opposite force. So there is no translatory motion. The electric dipole will not move. So no translatory motion. You know what is meant by translatory motion? Now imagine one of the girls pull me with larger force. Okay, if the girl behind me pulls me with larger force, naturally I move towards her. Or there will be translatory motion. In this case, depending upon whichever is greater, you know, E1 is greater. So this force is greater. So naturally it moves. Okay, it has a movement. The force it moves in the direction of the electric field. So we are talking about force on a dipole, not in a non-uniform electric field, in a uniform electric field. So this much must be there in your note. It's already there in the notes. I was saying this is the first part of a long answer question. That is what happens to a dipole kept in a uniform electric field. So what we understood is that the total force is 0, net force is 0. Now please look at this stylus in my hand. Hope you are seeing this stylus. Yes? Are you seeing this?
Yes, ma'am.
Imagine this is minus Q charge and this is plus Q charge. Okay? And there is an electric field in the classroom which is uniform. Okay? Which is directed from that side to this side, or there is an electric field towards me like this. Okay? In this direction. And this dipole is kept like this. This is minus Q charge, this is plus Q charge. Plus Q charge experiences a force due to the electric field in the direction of electric field. So plus Q charge pulls this charge towards me. What happens to minus Q charge? Minus Q charge experiences a force minus QE. So it experiences a force in the opposite direction of electric field. What happens to this dipole? A force in this direction and a force in this direction. Okay, one force like this, one force like this. Are you getting it? So because of this force, when I add the two forces, what is the total force on the dipole? QE minus Q0. But it doesn't mean that the dipole stays still. The dipole will, see, if I take a pen or a scale or something in your hand like this, and if you push one end like this, and if you pull the other one with equal force, you can see that it starts rotating. So if I pull it this way and push it like this, it starts rotating. So there is no translatory motion agreed, but it undergoes rotatory motion. So what is the conclusion? A dipole kept in a uniform electric field undergoes a rotatory motion. Fine. Or when do a rotatory motion appears? You learned in class 11 the term called torque. Torque is an analog of force. Force is the term we use in translatory motion. When we talk about rotatory motion, we use its analog torque. And you learn that torque is equal to distance multiplied by one of the forces. Perpendicular distance between the two forces multiplied by one of the forces. R cross F. Torque is equal to R cross F. You learned this in plus one. Yes, so.
Yes.
Yes, ma'am.
What is the name of the chapter where you learned all these things?
System of particles.
System of particles. What is the correct name of the chapter, sir?
System of particles and rotatory motion.
Yeah, exactly. Rotatory motion, you learned about different parameters what we use to explain motion along a circle or any rotatory motion. So here also we have to recollect all those things because now our dipole is not undergoing a translatory motion, but it undergoes a rotatory motion. Now we wish to know if it undergoes a rotatory motion, what is the torque on it? Wherever there is rotatory motion, there will be a torque on it. So the next task for us is what is to find out what is the torque on the dipole. So torque on the dipole kept in net rule. So we found that the net force on the dipole is 0. Next is what is the torque on the dipole. So torque on the dipole. So torque formula we know that is R cross F. Okay. Torque. Which letter you use to denote torque? It is tau. T-A-U. Tau. Greek alphabet. Tau is the letter we use to denote torque. So torque on the dipole is equal to, the definition is, it is torque is, you can calculate torque by multiplying one of the forces. So one of the force means one is QE, other is QE. Their magnitude we want. So one of the forces multiplied by, we have to multiply by the perpendicular distance between the two forces. What do you mean by perpendicular distance? This is my minus Q charge. This is the plus Q charge. It experiences a force like this. This experiences a force like this. What is the perpendicular distance between them? See? Here is our dipole. This is one force and this is another force. These are the two forces. And this is not the perpendicular distance between them. This distance we know. There's a name for this distance. What's the name for this distance? This is plus minus Q charge. This is plus Q charge. What is this distance?
2a.
It is 2a. It is the length of the dipole. We know that. But that is not the perpendicular distance between them. Perpendicular distance between them is here. This is the perpendicular distance. This distance is the perpendicular distance between them. I can't multiply QE into 2a. 2a is not the perpendicular distance. I would like to know what is this distance. And how can you find out? The inclination is given as theta. Dipole is kept at an angle theta with the electric field. This angle is already given. Can anyone tell me if this theta and this 2a is given? What value I can take for this perpendicular distance? One of you please tell me.
2a sin theta.
How did you get? Looking at this triangle, sin theta is equal to opposite side by hypotenuse. So this by 2a is sin theta. So 2a sin theta is nothing but this distance. So this is the perpendicular distance is what I need. So I need to multiply this with 2a sin theta. Okay. Now are you seeing any few terms there that you can merge into one? In this expression, are you seeing something that you can reduce into one single notation?
And Q
Q into 2a.
You can make it as Q into 2a as Q into 2a is
Dipole moment.
dipole moment. P and then E is there, then sin theta is also there. So I can rewrite this as P sin theta. So I got torque. I got an expression for torque. See, torque is P sin theta. Remember, just like force, torque is also a vector quantity. So it is not enough to write P sin theta. I would like to know in which direction torque acts. Is it in the direction of dipole moment or is it in the direction of electric field? Because both are vectors. It has its own direction, it has its own direction. Direction of dipole moment is like this, direction of electric field is like this. Then in which direction torque acts? That also we need to express. It's easy to get the direction of the product of two vectors. Okay. If I change this PE sin theta in the format P cross E, all of you learned A cross B is equal to AB sin theta. So I'm also rearranging torque as P sin theta as P cross E. What is A cross B, children? You learned not dot product and cross product? Yes, so.
Yes, ma'am.
Yes, ma'am.
When will you use, or if I'm talking about vectors or scalars, where do you find vector product and where do you call this as a vector product, obviously, because it's the product of two vectors. Okay, you know, product of or vector product always gives another vector. You get torque if P cross E, its product also must be a vector quantity. So torque is a vector quantity because it's a vector product of two different vectors. Now, if you know this, then tell me what is the direction of torque. According to this, I told you this we are doing to get the direction of torque. In this expression, can you tell me what is the direction of torque? Torque is equal to P cross E. Anyone? How do you get the direction? Torque is equal to P cross E. Vector A is equal to vector B cross vectors. I hope you know that this is not equal to C cross B. Are you aware of this? A cross B is not equal to B cross C. Am I right? Or both are same? Did you learn all these things children last year? Yes or no? Vector product. You learn? Now, for time being, what you all have to remember about this product is the meaning of A is equal to B cross C is that the magnitude of A is equal to magnitude of B multiplied by magnitude of C multiplied by sine of the angle between them. This theta is the angle between these two. Vector A is equal to product of cross product of B and C, meaning its magnitude is the product of these two multiplied by sine of the angle between them. Theta is the angle between these two, not between this one. It is between these two. Now, being a vector quantity, what is its direction? Direction of A is perpendicular to both B and C. This is very, very important. All of you have to remember this. When I write torque is equal to P cross C, the magnitude of torque is P multiplied by E multiplied by sine of the angle between P and E. And what is the direction of torque? Direction of torque is perpendicular to both P and E. Both P and E, not only for P or E, both P and E. What is the meaning of that, students? Suppose I have a vector, one is acting like this and another is acting in this way. Okay. This is my vector A and this is my vector B. It's not necessary that they should be perpendicular. They can make any angle. And for convenience, I'm taking they are like this. Now, what is the direction of the product of them? Not cross product of them. Cross product. Let the product of this cross product is A cross B. Then what is the direction of this one? Its direction will be perpendicular to this and this. You know, perpendicular to this can be into the board or away from the board. Am I right? There can be two perpendiculars. One is like this, into the board. The other is towards me. Then I have to specify, is it into the board or away from it? Okay, because it can have only one direction, either into the board or towards me. You know, into the mode or towards me, both are perpendicular to A and B. If I write, if I say that, okay, if I go like this is not the direction because this is perpendicular to this one, but not perpendicular to this. So this cannot be the direction of the product. So it has to be either towards me or away. How do you know whether it is towards me or away from me? The
Right hand screw rule.
Yes, you can use right hand screw. Who said it? I have.
Fauzi ma'am.
Who is it? Pause. What you can do is you take a screw, okay, and keep it at this point, right? You turn it from the first to the second. It is A cross B. So I have to turn from A to B. Suppose this is B to A. If I want to know B to A, then I have to turn from B to A. Now it is A cross B. Let me turn it A cross B. You know, a right hand screw, if I pull or if I keep rotate like this, it moves into the hole. Are you getting it? So the direction of the product is into the hole. Suppose this is, I want to know what is B cross A. Then what should I do? I have to move like this. When I move like this, you know the screw will come out. So the direction is away from the hole. So that's about finding out. I know all of you know all these things because it's 7th standard. Vectors, you all must have learned it properly. Now, here my aim is the direction of torque is very, very important. It is perpendicular to both P and E. So, when you get a question to calculate the torque, you must know that torque is equal to P cross E or PE sin theta. Here, please remember theta is the angle between P and A. P I can keep. See, this is my electric field. Dipole I can keep like this, or I can keep like this. I can keep like this. That is my convenience. And whenever you keep P, whichever be the direction of P, then PE sin theta is the angle between P and B. So take the angle between P and B. So angle between P and E can be 0 or angle between P and E can be 0 to 180, any value. That is how you are keeping it. Okay? Depending on the question, you give the value of that to your now, what we want is torque tau, which is equal to P cross E. Now, let me ask you a question. It's a common one mark question connected to torque. Okay, let me write it down on the board. Is it clear, children? Is my board visible?
Yes ma'am.
Yes, ma'am.
Can you see it? Can you see what
Yes
I'm
ma'am.
writing?
Yes, ma'am.
Pairs, okay, find out the two pairs of perpendicular. Please give me answer. Anyone got it? We got it over. No. No one got the answer. It's not physics, it's maths. Instead of P cross E, I write. Instead of P cross E, I can even write A is equal to P cross E. Then this purely maths. So the question is, which are the two? Sorry. Which are the two perpendicular vectors in A is equal to B cross C? I'm making increments. Please tell me two pairs of perpendicular vectors. Please remember what are things I told you about two vectors. If a vector is like this A, another vector is there like this B, if the angle between them is theta, I can write A cross B is equal to C. Okay. And the condition is that C must be perpendicular to both A and B. A and B are not necessarily be perpendicular. C is equal to A cross B. Now you tell me from A, B, C, which are the two pairs that must be always perpendicular.
A and C and B and C.
Exactly, it is A and C and B and C. This question comes like this. You go through previous year's questions, you can see. They instead of A is equal to B cross C, they write torque is equal to B cross C. So which are the two vectors which are always perpendicular in this? One is torque and this, other is torque and this. The children, what answer they write sometimes? So they torque is written as P cross E, and then for the question answer they write torque and E. They write P and E. P and E are not necessarily be perpendicular. So this is wrong. This is correct, and the next one is torque and. Okay. So the two pairs. This is one pair. This is another pair. These are 1 mark questions you can expect in the form of 1 mark or in the form of MCQs. Okay. Is that clear, children?
Yes, ma'am.
So we were with the dipole and the important things about dipoles are what is the electric field on the axial line, equatorial line, and what is the force experienced by a dipole, or prove that a dipole does not experience any translatory motion. You all know how to do it. You have to draw a neat diagram, and then under that you can write one sentence, that is net force is QE plus minus QE is equal to 0. Children, some children while writing answer they write total force is equal to 0 without writing QE plus minus QE. That has to be there. Okay? Otherwise, you won't get full mark. QE plus minus QE is equal to 0. Nothing else. If you write that much, meaning a diagram, neat, diagram, and net force is equal to QE plus minus QE, which is equal to 0, you get 2 marks for it. How easy to score marks there? Take a 5 minutes break. We will continue with the last part of the chapter. Okay.
Okay, ma'am.
Thank you.
list I have, I can go through the name list, but what is the use? Name and your face. No? That's what I want to see. Meghna, Navin, Nida, Aishwarya, Diya, Fatima, Chaitanya. Some of you I know because you used to text to me. Whether you are in uniform or not, please switch on, okay? Yes, Aditya, did you cut your hair?
Yes, ma'am.
Okay, once. Next time I'll go. Aishwarya, Atul, Atul, your profile pictures. This is scary for me. Who is Lakshya? No uniform. Where are you, Lakshya now?
I'm actually in there.
Ardra, Anand Krishnan. Okay, fine. Let us continue. Uh, we are moving on to the last part of the chapter. We are with electrostatics, electric fields, and the properties of charges when they are at rest. Dipole, we have almost completed the different properties of dipoles and the most important questions from dipole. The next thing what we want to, so as a recap, let me just go through the notes we have, okay? So if I left out something and that will be a reminder also for me. So all these things we have seen all these things, dipole moment, net force, all these things we have seen. Charge distribution. This side, then before I go on to the next part, I want to tell you what is the meaning of charge distribution, and then the next part. That's it. The next thing what I want to tell you is what is the meaning of charge distribution. We were talking about positively charged body, negatively charged body, or there is a negative charge, there is a positive charge like that. But when we come to practical cases, okay, we have objects which are charged. If I have an object in my hand and which is taking a sphere, I'm drawing as a circle as a two-dimensional figure. If you have a sphere in your hand, or if you have a cube, okay, and or if you have a thin rod, okay, all these are objects which I can charge. I can give charge to them. Or I can take a thin sheet, okay, very thin sheet, and I can give charge to it. I can say all these are cases where I can consider this as different charge distribution. I'm giving charge to all these types of objects, regular objects. Imagine I'm taking a thin sheet. For example, you can take one of the thin pages of your notebook, which is thin sheet. Or I can take a thin wire, okay, a copper wire, any thin wire that you see. I can give charge to that. I can give charge to a thin sheet, or I can give charge to a sphere or a cube. There is some difference, or for convenience, I can tell you about the charge density. What is the charge density once I charge it? What is the charge density of this one, like that? The meaning of charge density is charge per unit length or charge per unit area or charge per unit volume. When will I say charge per unit area? When will I say charge per unit volume? And when will I talk about charge per unit length? Let us consider a thin wire. Okay, imagine a very thin, long wire. Its length is very clear, it's very large. But compared to its length, you can see its thickness is very, very small. In such cases, I say, imagine I have given a positive charge to it. I can neglect it all other dimensions other than length. And I can say that I've charged this body and the charge per unit length, charge per length, charge per unit length. I can use the term charge per unit length for this particular case because it has only length which is much greater than its other dimensions. Now, if I take a thin sheet, I have to consider its length and breadth. It has no thickness, but it has certain area. I can neglect its area. In such cases, when I give charge to it, I say that charge. What is the charge I have given per unit area? So this is charge per unit area. This is charge per unit length. And if this is a sphere and this is a cube, I can't neglect any of its dimensions. It has its own volume. Everything is finite. So I say charge per unit volume. So depending on the situation, I can talk about charges as, see why I am saying charge per length, charge per area, charge per volume, etc. Because I can count the number of charges I have given, large amount of charges given. So for convenience, we use charge per unit length or charge per area or charge per volume. And usually charge per unit length is denoted by the letter lambda. Charge per unit area is denoted by sigma. And charge per unit volume is denoted by rho. These are the common notations we use for charge distribution uniformly. See, all these cases I am considering uniform charge distribution. So different cases of uniform charge distributions are charge per unit length. For example, a thin road, charge per unit length. Uniformly charged thin sheet, I use the term charge per unit area. Uniformly charged sphere or uniformly charged cube, I can use the term charge per unit volume. I use the letter rho. And what about their unit lambda? What will be the unit of lambda? Charge per length. So coulomb per meter. Charge per unit area, coulomb per meter square. Charge per unit volume, coulomb per meter cube. This idea you must have when I deal with the next part of the chapter. Okay. So shall I go to that part, the last part?
Yes, ma'am.
Now again, to understand the last part of the chapter, we need to talk about another physical quantity in the chapter that is called electric flux. Flux, F-L-U-X. What is the meaning of flux? What is the meaning of F-L-U-X flux? Anyone? Learning English from KG, right? KG or even before that. Please tell me what is the meaning of F-L-U-X? One of it is. Is that this flux we say, suppose one of you became famous in some way, your flux is put in the town or on the road somewhere. Is that flux? Is this the flux we use there? Or that is another flux? Or is there any difference? Aditya Rajendra knows the answer. Please tell me.
Yes, ma'am.
What is the spelling of that flux? We say no, someone has become very famous or something. Then we put their flags on the road, right? No, on the hoardings or something.
FLEX.
That is FLEX. Then what is the meaning of this flex? This flex has a meaning flow. Okay, or current. Electric flux, flow of electric field lines. Okay, that is the meaning of electric flux. Flow of electric field or electric field lines. Now it's a physical quantity, so it should have a proper definition and an expression. Usually electric flux is denoted by a letter phi. This is read as phi. Recap for that again, phi. Let us see what is this electric flux. Electric flux is defined as the dot product of electric field intensity and the area. E dot ds. It's a dot product. A dot b. A dot b can be written as A b cos theta. So what is theta here? Theta is the angle between E and area. E you learn as electric field, and you learn that electric field intensity is a vector quantity. This E is nothing but electric field intensity. It's a vector quantity. Dot product and vector product are cross product or dot product. It's always between vectors. Am I right? Yes, so. But here I put a dot product, and E, it's a vector. And this part is area. What do you know about area? Is area a vector or a scalar?
Vector.
area is a
Scalar.
scalar. You learned it as a scalar. You learned area as a scalar. But today I'm going to tell you that area can be considered as a vector. Okay. We call it area vector. Okay. When I say area vector, okay, so if I have this surface means my mobile and this surface, it has an area vector. Area vector is a physical quantity. It should have some magnitude and direction. If I call it as a vector, then what is this is the surface of this mobile? What is the magnitude of this area? I can measure this length. I can measure length and breadth. Multiply. I get its area. Magnitude I get. Then what about how can I call it as an area vector? Area vector means I should tell it about its direction. So area vector of the surface, okay, is nothing but magnitude I got. Its direction will be always outwards, away from the surface and perpendicular to it. What is that line which is away from the surface and perpendicular to it? It is a line. See, this stylus indicates area vector's direction, and the direction must be towards you, away from the surface or towards you. Then if I take the other side, suppose I take like this. There is a surface here, there is a surface here. What is the area vector, direction of area vector of this surface and this surface? For this surface, this vector which is projecting or the directing in this direction, away from it. This is the area vector direction, and for this surface it is in this direction, away from it. If I keep it like this, the area vector has a direction upward. This bottom surface has a area vector directed towards the ground. Did you understand what is the area vector? Area vector.
Yes, ma'am.
Quantity which is a vector. Its magnitude is same as that you know how to calculate area already for any surface. Then what is this direction? Its direction must be always outside and perpendicular. So this is also a vector for us. And we know that dot product of two vectors is always a scalar. We learned it. If you take dot product of two vectors, its magnitude will be a scalar. So electric flux is a scalar quantity. Register in your mind, it's a scalar quantity. It is denoted by the letter phi. Then unit. These are the things, see, you are learning a new physical quantity. So you must know all these things. What is it? I'll define it. I'll explain that. Before that, remember the word you use, sorry, the letter you use to denote it as phi, its expression is E dot ds, E ds cos theta, where theta is the angle between E and ds. And it's a scalar quantity and its unit. Electric field unit, we learn Newton per Coulomb. What is the unit of area? Meter square. So unit of electric flux is Newton meter square per Coulomb. So these are the basic things about electric flux. Now you should understand what it is exactly, why we study about it, or what is the meaning of it. Why do we study all these things? I hope you all remember the things I wrote here. What all things I told about electric flux, I know you remember. Now we'll see what exactly electric flux means. Imagine, children, that I have a surface like this in my hand, okay? And someone is throwing, imagine it's a big thing, and someone is standing in front of me, and they are throwing some chocolates, okay? And the condition is this: the chocolates which hits, okay, on this surface, I can take. And since we all love chocolates, I wish maximum chocolates to touch on the surface so that I can take all those chocolates. And I can keep this surface in any way I can keep it like this, I can keep it like this, in any way I can keep it. But they throw chocolates in a perpendicular direction. From there, they are standing in front of me, they are throwing, see, they are throwing in this direction. Right? So if I wish to get maximum chocolates, shall I keep my mobile like this or like this or like this? How should I keep? I want to get maximum chocolate. Only the ones which hit this surface I can take. So will I keep it like this, or will I keep it like this, or like this?
Second way, the last one.
Because if I keep it like this, maximum, they are coming in this direction, so maximum will pass through it. Now you forget about chocolates. Imagine, there are electric field lines in the classroom. They are coming in the same direction as chocolates are coming. Okay. Now, if I keep it like this, maximum field lines will pass perpendicular to the surface. If I keep this surface, if I slowly rotate this, you can see that the number of field lines passing normal to the surfaces keep decreasing. It becomes minimum now. Okay, in this position it is minimum. Now, why I'm trying to tell you is this electric flux. Okay, if I have a surface, imagine these are electric field lines, and if I have a surface and if I keep that surface in this direction, okay, imagine if I'm keeping it perpendicular to it. If I keep the surface perpendicular to it, maximum field lines will pass through it. And if I change the orientation of the surface, the number of field lines passing through the surface normally, normal to the surface, is keep decreasing. Now, electric flux is defined as a measure of number of field lines, electric field lines. It's a measure of number of field lines passing normal to the surface. So electric flux we always talk for a surface. What is the electric flux of a particular surface? Electric flux for a particular surface is a measure of number of field lines passing normal to it. And its expression we learned right now is, the expression for that is written as, we use the letter phi, which is equal to E dot ds. Okay, it is E ds cos theta. So if I want to get large electric flux, that is large number of field lines passing through the surface, what are the ways, or what are the different methods to increase the number of field lines passing normal to the surface? How can I increase the value of phi? I can increase the value of phi by increasing the electric field intensity. Meaning, if I create a large field line, fine, then the number of field lines coming from it increases. If the number of field lines coming increases, naturally my surface will, a large number of field lines will pass through my surface. So one way of increasing phi is increasing this. Next method, what is the next method? Okay. This is the surface. Only 5 chocolates they are sending, then only 5 can hit here. Imagine they are sending 5,000 chocolates. So the number of field lines increases. So if electric field intensity is greater, flux will be larger. If I increase the area, instead of a small area, if I use a big area, okay, again phi will increase. So increase the value. And what is the third method of increasing phi? The third method is changing the value of theta, change the orientation. Instead of keeping like this, keep this way. So change the orientation of your surface with the electric field also matters. So there are 3 things which decide the value of electric flux. Why I repeatedly say is that you all remember that phi is equal to E dot ds. You think that phi increases when E increases and dx increases. It also depends on theta, the orientation. So, what is electric flux? Electric flux is defined as a measure of field lines passing normal to a surface. Okay, and unit, other thing I told you, and large number of. So, when you take for example, if I take a charge Q, I have a charge Q. You know, if it is a positive charge, you all know that there will be large number of field lines moving like this. I can move field lines like this. All these are. How many such field lines will be there, children? Can you tell me how many such field lines I can go? What is the maximum number of field lines I can go? Please, one of you tell me fast. Tell me how many field lines will be there?
Infinity.
Infinity. Now I'm going only this much. All these are field lines. So I didn't write plus q here, but seeing that sign, you know this is a plus q charge. Okay. Now, let me take a small surface. Okay, I have a small surface in my hand, and it is of this shape. I have a small surface of this shape. Right. If I keep it here, you can see around 1, 2, 3. 3 field lines are passing through. Fine. If the same thing, if I keep it, if I'm taking from here, and if the same thing, if I keep it, you can see, I mean, this is little bigger it became. So in that case, it will be like this. Here you can see 1, 2, 3, 4 field lines are passing through it. The same one, if I keep it, only 2 are passing through it. So the reason you know the field lines near a charge will be crowded. As you move away from it, it is becoming less and less dense. Now, what is how to calculate electric flux? Electric flux is, if I want to calculate what is the electric flux with this, I have to multiply electric field. So to calculate electric flux, electric field multiplied by the area. Imagine there's an area ds. Okay, EDS. Now, since I kept perpendicular to this one, EDS is equal to EDS cos theta. Cos theta is the angle between E and DS. What is the direction of E? E is like this. Okay. What is the direction of area vector? I kept it perpendicular to that. So area vector is a perpendicular vector to the surface. So area vector is also having same direction. So angle between E and this is the direction of E, this is the direction of DS, they are parallel. Parallel meaning this becomes 0, cos 0 is 1, so flux is becoming EDS. I get a flux equal to EDS. Imagine the same surface I kept like this, so that DS is like this and E is like this. Okay, DS is in this direction, E is like this. Area vector like this. Electric field intensity like this. So angle between them becomes 90 degree. So what is the flux? Flux is equal to EDS cos 90. You know cos 90 is 0, so I get as 0. This is what I told when you throw chocolate, okay, in this direction, EDS, okay, electric field lines coming, area vector DS, they are parallel or anti-parallel, whatever it is, I get maximum flux. If I keep it like this, area vector is like this, chocolates are coming in this direction, so angle between them is 90, so electric flux becomes 0. Any other value can be, depending on the value of theta, it can be, the minimum value will be 0 and the maximum value will be EDS. Please keep these things in your mind, what is electric flux and how to calculate it, or when it becomes maximum, what are the ways of increasing or decreasing electric flux. I hope you got it. We have already learned one very important law in the chapter, that is Coulomb's law. The next law that we are going to learn in this chapter is this is one of the fundamental laws in electricity or in electromagnetism. This is one of the fundamental laws. Known as Gauss. Gauss is the name of a scientist. Gauss's law. Why we study about Gauss's law? Yes, we would like to know when there is a charge Q. We know how to calculate electric field at a distance. All of you know how to calculate this. The form value of electric field at the point P is P is equal to K Q by R square. This is how it is. This is easy for one charge. If I have one more charge here, if this is Q1, electric field here is like this. If I have one more charge Q2 here, what you do to find out this, you take this as R1 and this is R2. Then you find out what is E2, then QK, Q2 by R2 square, and take the vector sum of it. If there are 3 charges, 4 charges, if there are millions of charges, this way of this calculation is not going to be easy. Okay. For example, if you have a body, I have, imagine I have a cube in my hand. I gave such a cube. I gave 1 million positive charge to it. And I wish to know what is the electric field at this point. Or I have a thin sheet. Okay. I take a thin sheet like this and I give 2 million positive charge to it. And I wish to know what is the electric field at this point. Imagine calculating the electric field at this point due to 1, 2, 3, 4, like that million, and then finding out resultant electric field is not going to be easy. And for this, we have a very convenient way, okay, who help us for finding out this in a very simple manner. It's nothing or none other than Gauss. And using this law, on Gauss's law, we can easily find out electric field produced by charged regular bodies, any charged body. If you are asked to find out what's the electric field it creates, we can go for Gauss's law. Okay. So this is what we are going to do now. How to calculate Gauss's law using this. And first, let me state what is Gauss's law. It says in expressions, very easy to write. You know phi. Right now, I told you what is phi. It has electric flux. According to Gauss's law, okay, he says that E dot ds. I'm writing an integral here, which is a closed integral, E dot ds, according to him. Closed integral E dot ds, which is equal to phi, is nothing but Q by epsilon naught. This is what is given by Gauss. This expression, okay, given by Gauss is known as Gauss's law. How do we write it in a sentence? Is a law, but we have to state it. So it says that the total electric flux through a closed surface, the total flux, we are talking about electric flux through a closed surface the field lines passing out of this surface. This goes field lines passing through it. It is very easy for you. You just multiply 1 by epsilon naught, the charge you kept here to go. This is nothing but the flux. If you have another body, suppose I have a cube in my hand, I kept a charge Q here. I wish to know what is the field lines coming out here. What is the total flux coming out of this? What I can do is, I can just multiply by 1 by epsilon 0 by what charge I kept in. If I get 5 coulomb, what is this? So I have easy to find out the flux enclosed by any. This is applicable only for closed surfaces. So to find out the flux through a closed surface, it's very easy. Now the question is, why do you want to find out the electric flux coming out of different surfaces? See, actually, whenever you want to find an electric field due to a closed surface, this is how I started. I have a cube in my hand, okay, which is charged. I wish to know what is the electric field at this point. I told you the difficulty of using Coulomb's law and finding out electric field. Now you see, if I use Gauss's law, I get what is called electric flux. According to this, electric flux is 1 by epsilon 0 times charge. If I can calculate electric flux, if I know the area, then it is easy for me to find out. This already I got this value. Then divide by ds, I get E. So to get electric field, it is enough to know electric flux. Electric flux easy I can calculate using Gauss's law. So this is actually charged bodies. We can use Gauss's law. And why we prefer Instead of finding out electric field directly, why do we find out electric flux? There are one thing you can see that electric flux is equal to, according to, if you use this law, it is electric flux is equal to Q by epsilon. ECT calculation. Only thing you need to know what charge you have given. If I give 5 coulomb of charge, I don't want to know how many electrons I have given. I just want to know what's the total charge. So total charge by epsilon naught. I get electric flux. Another very important thing is that electric flux is a scalar quantity, whereas electric field is a vector quantity. Dealing with scalar quantities are much easier than dealing with vector quantities. So if I want to find out this vector quantity, it is enough to find out the scalar quantity first, and from there I can get what is. Are you getting me, children?
Yes, ma'am.
So we are talking about Gauss's law, and the statement of Gauss's law is there. Please go through the statement. Please go through the statement, and hereafter, till your board examination, physics, most probably usual time of physics board examination is March 5th, March 1st or 2nd or 5th. It always happens before 5th. Normal conditions. Okay, I hope the same thing will happen this year as well. So till then, you need to remember one thing. The moment you listen to the term Gauss's law, immediately what should come in your mind is this expression. Q is equal to Q by epsilon. Sorry, phi. Flux phi is equal to Q by epsilon. I hope you learn it now itself. Flux, electric flux phi is equal to Q by epsilon naught. This is what Gauss's law says. Then you need to write it sentence and down. But if you remember this, it's easy for you to convert it into a sentence. So any day, any time, okay, even you are sleeping, when someone asks you what is Gauss's law, what you should tell is Q by epsilon. Is it thorough, children? All of you can say, when I ask what is Gauss's law, the first thing you say is that flux phi is equal to Q by epsilon naught. Then I ask, no, don't tell it that. Tell in complete sentence. Okay. Then you can say in complete sentence, the total flux through a closed surfaces 1 by epsilon 0 times the charge enclosed by the surface. Now, let us apply it in some cases. Let us see. Actually, for examination purpose, we have to study 3 applications of Gauss's law. Applications of Gauss's law, I mean, how to find out electric field due to 3 types of charge. One is a linear charge distribution. Linear charge distribution is the first case where we apply Gauss's law is charge thin, long, uniformly charged. Okay, uniformly charged, thin, long. This is our first application. It's a linear charge distribution. Linear charge distribution, we will neglect all other dimensions except strength. So we'll be talking about its lambda or its linear charge density. We call it linear charge density. The second application that we need to learn is uniformly charged. This is a common term, uniformly charged. Thin sheet. Sheet. So I have to consider its area. So I will use the sigma over. And the third case where we are going to apply it as uniformly charged spherical shell. Spherical, it's not sphere. If it is a sphere, I have to consider all its volume. But this is a spherical shell. For example, you take your ice cream football or whatever. When you cut it, you know there is nothing inside. Only surface is there. Imagine that surface is very thin. We call it spherical shell. A spherical shell is a holosphere, and its surface is very thin. Since its surface is very thin, I don't have to consider its volume. It's enough to consider the area of the surface. So here again, don't confuse, I'm not talking about a solid sphere. If I'm talking about a solid sphere, I have to use volume charge. So these are the three cases we are going to apply Gauss's law. So what I've written is big, and you might know what all things you are going to study. Nothing. All these applications, it takes 2-3 steps. That's all. Very easy to derive. Okay. So before we go for that, what are we going to do? We are going to apply Gauss's law. Let me tell you simple way how Gauss's law is useful to us. For that, imagine this is a surface. Students say closed surface. Okay. And I kept a 5 coulomb of charge here and a minus 2 coulomb of charge. The question is, what is the electric flux? We learned Gauss's law. We know how to apply it. It is Q by epsilon. Or it is 1 by epsilon naught times the charge enclosed by the surface. Please tell me what is the charge enclosed by the surface? Tejas, what is the charge enclosed by the surface?
It's 3 coulomb.
I didn't get it. 3 coulomb. Yes, good. 5 plus minus 2. So it is 3 coulomb. So into 3. So flux is 3 by epsilon. Very easy to calculate. If I add here, suppose there is minus 3 coulomb also, what happens? Plus 5 minus 2 minus 3. So in this case, it will be 1 by epsilon 0 times 0, or flux will be 0. Why? What's the meaning of saying flux is 0? There are 3 charges inside, and I'm saying flux is 0. What does it mean? Is that for that, let us see once again. I have a sphere like this. Okay. I have a plus 2 charge here. How will I draw the field lines? I have to draw the field lines which are coming out of the surface like this. Imagine, for convenience, I am drawing 6 lines. All 6 lines are outwards because plus 2 charge. If I keep a minus 2 charge, coulomb charge also here, okay, how should I draw the field lines? Field lines into this one. So what is the total number of field lines you have? 6 outwards and 6 inwards. 6 out, 6 in. So total will be 0. Instead of doing like that, what you did, you added the total charges minus 2 plus 2. You got flux phi is equal to 1 by epsilon 0 times 0. You got the answer as 0. Is that clear to you, children? If I keep, imagine instead of minus 2 plus 2 and all, I am keeping, first I get minus 2 coulomb and then I get minus 1 coulomb. If it is minus 1, the field lines coming into will be less because one is plus 2 and the other is minus 1. So there will be some flux lines balance. Right? Now, keeping these things in mind, children, we will go for Gauss's law application in the next class. Right? So today, please go through the notes. I've sent both the notes. Please go through all the things. The second one, what I sent is only for examination purpose. Only the important derivations and things are there. So please go through the both things and get ready for test. You know, the next class I'll conduct a test. And one more very important thing that you have to tell your parents is that there will be a parents meeting on Friday. That is coming Friday. This week, last Friday, there will be a parents meet online at 12:10. Are you getting it, children?
Yes, ma'am.
Please pass this message. We'll be sending message in WhatsApp group also. So you just tell them there will be a meeting. Okay. So that's it, children. See you. I'll meet you in our next class.
Thank you, Miss.
Thank you.
Yeah.
Thank you.
Thank you.
Teja Miss, bye. Teja Miss.
What about others? Fatima, Mirza. Okay, Aryabhya, it's okay. Mamta, okay, it's okay. Others, see, unless you have a genuine reason, please on the camera. Okay, if you have any network issues or if you are sick, then it's fine. Okay, otherwise, Aaron, Harinandan,
Yes, ma'am.
quickly children, Harinandan,
Ma'am.
Atul Bini, turn on the camera. Okay, finish writing your notes. Your notes is complete. Yes? Everyone completed your notes? Risha? Finish writing? Okay, now everyone just take a notebook and just show it. On the day, last day, I just saw only few. Okay, everyone. I saw Ifa, Zetman, Niranjana, then Anaka, you showed me, no, last day? No. Yes, Alvita, okay, Dhruva, okay, Diya, Matu, Krishna Priya. What about others? Quickly. Diya, Sebastian, good. Then Anchal, yes. Anand Krishnan, last class you are not there. Anand, what happened? One period you are not there, the next period you joined. But
It's Wi-Fi problems that day.
so next period I just calling you because first period is marked absent. That's what next period I was calling you. But no message. Okay. Did you write the notes, Anand Krishnan? Yes, Aditya, if you have a network issue, it's fine. No need to turn on the camera. Really, if you have it, it's fine. We can't help it, no? Anand Krishnan, show your notebook. Did you got the notes?
I didn't write note.
You didn't write. So I can see you. There's no light. You didn't write it, Anand Krishnan? Say yes or no?
No, miss, I didn't write. That's
Okay. You have get the notes from your friends, copy it, and must send it to me personally in my WhatsApp. Is that clear?
yes, miss.
After the class, write and just send it to me personally. Hardly a page. Okay. Mohammed Ismail. Show your notebook. Quickly. Yeah. Okay, Aditya, did you write? Mohammed Ismail, where I can see you. Yes? Aditya, did you write? Yes. Okay. Hope everybody showed me only the correct notes, your notes, not some other subject, because through camera everything won't be clear. Okay. So I trust you people. Okay. So whatever we say, you do it. Okay. That's what though you show in front of the camera, I'm saying okay. Okay. Trusting that it is the notes which what I expected. Okay. So we just quickly start the class. So in the last class, we have just completed how microbes are useful in household products, right? Okay. So Devangana. Devangana.
Yes, ma'am.
Yes. Which is the first household products you have seen last class? Everyone take page number 181 in your textbook and just go through that quickly and be asking me questions. First household product?
Dough.
No. First one what we saw?
Miss curd.
Curd.
Curd, yes. Name of the microbe?
Lactobacillus or lactic acid bacteria.
Okay, lactobacillus are lactic acid bacteria. Okay. Meghna P.
Yes, miss.
What are the beneficial of eating curd?
No. It checks,
What is the role of lactobacillus?
checks disease causing microbes in the stomach.
Two benefits of lab is
Increase nutrient quality of milk.
yes, increases nutrient quality. Which nutrient?
Vitamin B12.
Vitamin B12. Second one. Second one. Uday, tell me the two benefits of lab.
They partially digest the milk proteins
That is the
and
yes, yes, still.
they increase vitamin B12.
Yes, they increase vitamin B12, and by eating that, what's the other benefit? Tejas? What's the another benefit? Open the notebook, open your textbook, everything is given. Children, you have to learn daily portions. Otherwise, it will be very hard. This is a board question. Repeated board question. Yes, Tejas?
Ma'am, it checks the growth of disease-causing microorganisms in our stomach.
Yes, good. Okay, checks the growth of the disease causing microbes. Okay, Muhammad Ismail, I didn't see your notebook. No, the camera is not on. I couldn't see you. That's why I told you. Now show me. Yes. Okay. Then why did you switch off your camera? You are not in uniform. That's the reason. Yes. So if you are not switching on, also we can understand you are not in proper uniform. Okay. It should not be like this. Must be in uniform. Okay. Rohit Sunil.
Yes, ma'am.
Which is the next food item?
Dough.
Dough. Which is the microbe used? For making idli and dosha, which is the microbe used?
Saccharomyces.
No, Anna Biju.
Yes, ma'am.
For making idli and dosha, which microbe is used?
We use bacteria and it is from environment.
Yes, good. Okay, bacteria is used. For making vellappam and all, we use yeast. Okay, so Aaron.
Yes, miss.
What's the scientific name of yeast?
Miss, is that big name sack or something?
Huh? You type the message. The camera, the spelling is wrong. Harinandan. Children, you have to respond quickly after because
Yes, ma'am.
Yes, Harinandan. What's the name of our yeast?
Saccharomyces cerevisiae.
That is used also for making batter. Is it not? Okay. So, which is the process by which this batter for making idli or for making vellappam undergoes when this bacteria? By which method, Gopika?
Fermentation.
Yes, good. By fermentation. Riya Pravesh, what is produced during fermentation? Which gas is produced?
CO2.
Because of that, what you can see in the batter on the dough?
Air.
Ah.
Air bubbles.
Yes, air bubbles. Okay, or the puffy appearance. So when you prepare dosha, you can see many air bubbles. Is it not? Okay, the puffy appearance in the dough is due to the production of carbon dioxide, and the microbe undergoes anaerobic respiration by a process known as fermentation. Okay, so which are the other products, Bhadra Baiju? Bhadra.
Yes, ma'am.
Which are the other products fermented?
Toddy,
Ah.
fish, soybean, bamboo, bamboo shoots.
Which is a traditional drink seen in southern India?
Toddy,
What's that?
toddy,
Toddy. Okay, so how toddy is prepared?
by fermenting the sap from palms.
Okay, by fermenting the sap from palm. Okay. Mamta? Mamta?
Yes, ma'am.
How is cheese produced? Can you tell me one microwave cheese? It is used for preparing cheese. That is one microwave.
One. Ma'am.
Name of the cheese and the microbe used. Yes, Mamta, quickly. If you don't know, say, ma'am, I don't know, so I can go to next person.
Ma'am, I don't know.
So take the page book, page number 181, find the answer, I'll be back. Atul Bini,
Yes, ma'am.
just give me the name of a cheese and the microbe.
I guess Propionum bacteria Shermani makes Swiss cheese.
So which is the type of microbe there? Propionibacteria Shermani comes under?
Bacteria.
Bacteria. Good. Okay. Ryan? Ryan?
Yeah, yes, ma'am.
One more cheese name. Given in your text.
Roquefort cheese.
Roquefort cheese. Okay, so which is the microbe there?
It is formed by the ripening with fungi Penicillium roquefort.
Roquefort tea. Yes, good. Okay, so till that we have seen. Okay. Is the board chair, children?
Yes, ma'am. Yes, ma'am.
Okay, so this is the just the points what we have discussed in last two classes. That is, microbes are present everywhere in soil, water, air, inside our bodies, and that of other animals and plants. They are diverse like protozoa, bacteria, fungi, and microscopic animal and plant viruses, viroids, and prions, which are proteinaceous in nature, which are infectious agents. These are the different classification or diversity of microbes. Okay. And how microbes are used in household products. First one is the production of curd from milk, lactobacillus, commonly called lactic acid bacteria. And for making food such as dosa and idli, it is fermented by bacteria. So the term fermented bacteria is important. Okay. And the puff appearance is due to the production of carbon dioxide gas. And okay. And for making bread, we use baker's yeast, that is a fungi, that is comes under yeast. Okay, fungi group, Saccharomyces cerevisiae. And traditional drinks are also made by fermentation, okay, by the microbes. And one example is the toddy, a traditional drink, and it is obtained from fermenting sap from palms. Okay. And some other foods are also fermented, that is fish, soybean, and bamboo shoots. And cheese, which is one of the oldest food items, different varieties of cheese we have, because for preparing type of cheese, different microbes are employed. That's why we have a different texture, flavor, and taste for the cheese. Okay, why? Because the specificity is due to the microbes. Which type of microbe we are using, particular type of taste, texture, everything will get it. Okay, so in your textbook you need to learn only two names of the cheese. One is the Swiss cheese, and it has a large hole. That large hole is due to the production of large amount of carbon dioxide. And which is the bacterium used? It is the Propionibacterium shermani. Okay, similarly the another cheese is there, the Roquefort cheese, and that is ripened by growing on specific fungi. The name of the fungi, I just told you the class, Penicillium roqueforti. Okay, that gives them a particular flavor. Okay, everybody thorough with this? Okay, Andrea?
Yes, ma'am.
Read the next one, microbes in industrial products. So which one we are going to see the next one? microbes in industrial products? Read.
Even in industries, microbes are used to synthesize a number of products valuable to human beings. Beverages and antibiotics are some examples. Production on an industrial scale requires growing microbes in very large vessels called fermenters.
Okay. Okay, Dia, let's ask.
Yes, ma'am.
Can you read that once again? Yeah.
Even in industries, microbes are used to synthesize a number of products valuable to human beings. Beverages and antibiotics are some examples. Production on an industrial scale requires growing microbes in a very large vessel called fermenters.
Okay. So, small microbes are used, okay, to synthesize many human valuable products. Even now, you know the vaccines, okay, at civil. So, many industrial products can be produced from vaccines, okay. So, if such products we cannot prepare in very small quantity, is it not? It has to be prepared large quantity. So for that we need a large vessel. What is the name of the vessel? What's the name of that vessel? Anyone? What's the name of that vessel? Yes, fermenters. Okay. So in the picture you can see large fermenters are there. Okay, Amil. 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 Children, can you hear me? Amil. No? Amil is not there. Ritvika.
Yes, ma'am.
You can hear me, Ritvika?
Yes, ma'am, I can hear you.
Okay. 1 second. Is the board shared?
Yes, ma'am.
Okay. So in this you can see you can see the big fermenters. Okay, so for producing any enzymes or producing any antibiotics or any vaccines or anything, to employ the microbes and to produce in large scale, we need the big vessel that is known as fermenters. Okay, we used to prepare or produce wine at home. Okay, so it's for our family means we won't need to have a big fermenters like this. Is it not? A small vessel will do because it is for a small group or a small number of people at home. Okay, so in that case we need a small vessel, but in a large scale production we need a big vessel that is known as the fermenters. Okay, so page number 181. Take a pencil, underline the second line under microbes in industrial products. Underline the second one, beverages and antibiotics. Underline. Okay, so which are the products produced using this fermenters, beverages and antibiotics. Okay. So how beverages is produced? Okay, how fermented beverages is produced? We'll see now. Vinayak. Read. Vinayak, read fermented beverages, page number 182.
Microbes, essentially yeast, have been used from the time immemorial for the production of beverages like wine, beer, whiskey, brandy, or rum. For this purpose, the same yeast, Saccharomyces cerevisiae, used for bread making and commonly called brewer's yeast, is used for fermenting malted cereals and fruit juices to produce ethanol.
Yes. Wait 1 second. Underline. So, which are the beverages? Different varieties of beverages, you know, isn't it? Beer, whiskey, brandy, or rum. Okay. So, why different varieties is there? Because the process is different. That's why whiskey, brandy, different varieties. As we said, no, cheese are different types of cheese available because the different type why it is available because we are employing different types of microbes. Similarly, beverages also, there are different types are there. That difference is due to the different way of processing. Okay. So, underline Saccharomyces cerevisiae, that is the same yeast which is used for making bread is used for making beverages also. Okay. So, it is also known as brewer's yeast. And what is the product produced there? Ethanol. Underline ethanol. So this is a 1 mark question. Okay. So Saccharomyces cerevisiae, it is known by 2 names. One is baker's yeast because it is used for making bread. It is also known as brewer's yeast because it is used for making the beverages from the malted cereals and fruit juices. And what is the one of the byproduct produced? It is the ethanol. Okay, so naturally, what will be the metabolic process? It is the fermentation. Okay, yes, then I continue.
Depending on the type of the raw material used for fermentation and the type of processing, with or without distillation, with different types of alcoholic drinks are obtained.
Underline. So why different types of alcoholic drinks we are getting? Underline the raw material, which is the type of raw material we are using, and that fermentation process is common for all, and that is different processing. Okay, in chemistry, I have learned about distillation and all. Okay, so some products are produced by distillation process, another are produced without distillation. So there also underline which are the products without distillation. Just continue. Vinayak, continue.
Wine and beer are produced without distillation, whereas whiskey, brandy, and rum are produced by distillation of the fermented broth.
Yes, underline. So wine and all we can prepare at home. Okay, it is without distillation. Okay, so next class just find out what are the steps to prepare wine. Anyone prepares wine at home, children? Anyone? Okay, prepares wine at home. Anybody? The parents or grandparents? No one. Okay, nobody? Okay, you can just find out what are the steps involved in the preparation of wine. Okay, we can just discuss in the next class. Okay, what about whiskey and brandy? They are produced by distillation of fermented broth. So sometimes you get questions like write the names of the beverages produced without distillation or by the process of distillation. Okay, so the second function of the microbe is how it is used in industrial products. Okay, so in this chapter we are going to learn about only 2 industrial products. One is the beverages, second one is the antibiotic. For that production, we need a large vessel that is known as fermenter. Okay, and why different types of beverages how we obtain? It is by the raw material and also the process. Depends on the raw material which we use and also the process. It could be by distillation or without distillation. Okay. Any doubt on this? Anybody? You can just put it in the chat box. Miss, I have a doubt. Is it clear? Okay. Dia Martin.
Yes, ma'am.
Read next one. Antibiotics.
Antibiotics produced by microbes are regarded as one of the most significant discoveries of the 20th century and have greatly contributed towards the welfare of the human society. Anti is a Greek word that means against, and bio means life. Together, they mean against life in the context of disease causing organisms, whereas with reference to human beings, they are pro life and not against.
So, what is the meaning of the word antibiotics? Anti means? Anti means? Anybody can tell me.
Against.
Good, against. And against who? Against the disease causing microbe. It is not against human beings. For us, it is pro-life. That is, it protects our life. Okay. So antibiotics are the chemicals produced by the bacteria, just or any other microbe to kill the disease causing pathogens. Yes, continue.
Antibiotics are chemical substances which are produced by some microbes and can kill or retard the growth of other disease-causing microbes.
Please underline, that is the definition for antibiotics. Okay, that's the definition for antibiotics. Mahira. 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 Aaron.
Yes, miss. Yes, miss.
Just tell me what is the definition? What is antibiotics?
Miss, antibiotics are chemical substances which are produced by some microbes and can kill or retard the growth of other disease-causing microbes.
Oh, okay. Adi Jaydeep.
Yes, miss.
Adi Jaydeep.
Yes, miss.
Just give me the definition for antibiotics.
Antibiotics are chemical substances which are produced by microbes and can kill or retard the growth of other microbes.
Okay, now Biju.
Yes, ma'am.
Give me the definition for antibiotics.
Antibiotics are chemical substances which are produced by some microbes and can kill or retard the growth of other microbes.
Okay, Arjun. Arjun.
Yes, ma'am.
Just read the next paragraph.
What?
Read the next paragraph. There she stopped.
You are familiar with the commonly used antibiotic penicillin.
Underline. So only one antibiotic is given in your textbook. Underline the name. Which is the antibiotic, Arjun?
Penicillin.
Yes, good. Penicillin.
Do you know that penicillin was the first antibiotic to be discovered and it was a chance discovery?
What do you call a chance discovery?
It wasn't intended.
What's that?
It was by accident.
So there's a term for that. Chance discovery. That is, scientists find something by chance discovery. That is, by chance they discover something. Anyone knows what's a term for that? Okay, if you know, just put it in the chat box. Otherwise, I'll tell you. Yes, continue.
Alexander Fleming, while working on Staphylococci bacteria, once observed a mold growing in one of its unwashed culture plates, around which Staphylococci couldn't grow. He found out that it was due to a chemical produced by the mold, and he named it penicillin after a mold, Penicillium notatum.
Okay, just 1 second. So in this picture, you can see Alexander Fleming. Okay, who is Alexander Fleming? What is his contribution? Anyone? What's the contribution of Alexander Fleming?
Discovery of penicillin.
Okay, he was the first person to discover penicillin, which is an antibiotic. Okay, as I told you, it is a chance discovery. It is known as serendipity. SERENDIPITY. Okay, it's a chance discovery. Actually, he was working on a bacteria known as the Staphylococci. Okay, so the page number 180, you could see one figure 10.3. No, where colonies of bacteria in a petri dish they are shown. Okay, like that, in a petri dish, he was working on the Staphylococcus bacterium. Okay, so in one of the culture plates or one of the petri dish or the culture plate, he could see a mold growing. That is a type of yeast or the fungi growing onto the petri dish. Okay, so in that area, the Staphylococcus bacteria was not able to grow, but other petri dishes we could see the growth of the Staphylococcus. Okay, so from that only he discovered that if penicillium is present, Staphylococcus could not grow. That is how the antibiotic was discovered. Okay, so when penicillium is injected, suppose if a person is suffering from this Staphylococcus bacterium, if this penicillin is injected, what will happen? It can kill the Staphylococcus bacterium. So this is a chance discovery. Okay, later this was used. Okay, to treat the wounded soldiers in World War II. Okay, and there was other persons like Florey and Shane. Okay, so they just found out the full potential of this penicillium, and the name of the antibiotic is penicillin. And the microbe is the Penicillium notatum. Okay, for the board question. Okay, Penicillium notatum is the name of the microbe, which is a mold, a type of fungi. Okay, and which is the product produced? It is the penicillin, and that can be used as an antibiotic against this bacterium Staphylococcus. Right? Okay, and these people were awarded Nobel Prize. Yes, Arjun, continue.
However, its full potential as an effective antibiotic was established much later by Ernest Chain and Howard Florey. This antibiotic was extensively used to treat American soldiers wounded in World War II.
Yes.
Fleming, Chain, and Florey were awarded the Nobel Prize in 1945 for this discovery.
Yes, underline 1 year the board question was this one. What was the contribution of Fleming, Chain, and Florey? Okay, that is the question. Underline last line. What was the contribution of these people who were awarded the Nobel Prize? Okay, what was their contribution? They only first isolated this antibiotic penicillin from Penicillium notatum. Is that clear, children? Yes, Nida Fatima.
Yes, ma'am.
Which is the antibiotic discovered by Alexander Fleming?
Penicillin.
Which is the microbe? From which microbe it is produced?
Penicillium notatum.
Okay, who was the other person who found out the full potential which can be used as an effective antibiotic?
Chain and Florey.
Okay, they were awarded what?
Nobel Prize.
For this
Nobel Prize.
awarded?
Nobel Prize.
In which year?
1945.
Yes. So that part, okay, that part also you have to learn. Okay, don't neglect certain last lines of the paragraph. Okay, so 1 year the board question was this. Okay, what was the contribution of these people in the field of medicine? Okay, yes. So Mahira,
Yes, ma'am.
read, continue. Don't know where he stopped. Children, you must follow the textbook. Fatima Mirza. Fatima Mirza.
Yes, ma'am.
Read.
What?
Louder, please.
No, ma'am. What did you say? I didn't get you.
You don't know where he stopped? Huh? Children must be attentive. Anchal.
Yes, ma'am.
Read.
After penicillium, other antibiotics were purified from other microbes. Can you name some other antibiotics and find out their sources? And
Whichever antibiotics are chemical antibiotics also, whichever we take for some diseases. Just type it in the chat box. Let me see few antibiotics name quickly. You continue. Anshul, continue.
Antibiotics have greatly improved from our capacity to treat deadly diseases such as plague, whooping cough, and diphtheria and leprosy, which killed millions all over the globe. Today, we cannot imagine a world without antibiotics.
So not only penicillin, we have n number of what's that? Antibiotics available in the market. Is it not? So please type 1 or 2 antibiotics name now. Children, just type 1 or 2 antibiotics name, at least few examples. 1 second. Yes, tetracycline. Then, good. Like this type. Vancomycin, erythromycin. Yes. There are many antibiotics. Chloroquinins. Then. Only that much. Amoxicillin. Okay, like that many antibiotics are available in the market. Yes, amoxicillin. Okay, azithromycin is good. Okay, so this we obtain from the microbes and they are used to treat the bacterial diseases, mostly the bacterial diseases. Okay, and they are given a list in your textbook like plague, whooping cough, diphtheria, leprosy. Okay, so these are some of the examples, a few examples to treat the disease using antibiotics. Okay, you need to learn the names alone for the exam purpose, but you can just find out the causative organism for these diseases. So just to know more about that. Okay, so next class, 2 work are given just to find out the steps how to you make or prepare wine. Second one is this one, plague, whooping cough, diphtheria and leprosy. Name of the causative organism and which type of antibiotic is used to treat these diseases. Just the causative organism and the type of antibiotic used. Okay. Nevin?
Yes, ma'am.
What's the homework I gave you now?
To name antibiotics, some antibiotics for the world and its diseases.
Just the name of the causative organism of the disease and which is the antibiotic used. Oh. So we have seen the beverages, we have seen about the antibiotics, and the last one is the chemical, enzymes and other bioactive molecules. Okay. So Parthiv, read.
Microbes are also used for commercial and industrial production of certain chemicals like organic acids, alcohols, and enzymes. Examples of acid producers are Aspergillus niger of citric acid, Acetobacter st acid, Clostridium botulism of butyric acid, and Lactobacillus of lactic acid.
Okay, so this is again a 3-mark question. Okay, sometimes the name of the microbe will be given. You have to find the organic acid or the vice versa. Okay, so on the board also you can see the name of the microbe and the acid produced. In that, only Aspergillus niger is a fungus. So other things are bacterium. Okay, so whenever you learn the name of a microbe, the type also you have to learn. Okay, so these are the 4 microbes. They used to produce different types of organic acid. Okay. Aditya?
Yes, ma'am. Ma'am, that page, there's some problem. That page, there's a problem for me.
Okay. Aishwarya? Aishwarya?
Yes, ma'am.
Read the next one. Quickly.
Yeast is used for commercial production of ethanol.
Yes. So
Microbes are
wait, yeast already yes in use to make bread, used for preparation of the beverages. Okay, so bakers is brewers is. Apart from that, to produce a chemical that is alcohol, which is used yeast. The same Saccharomyces cerevisiae is used for the commercial production of ethanol. Yes, next one. Wait.
Microbes are also used for production of enzymes.
So
Lipase,
it's used for producing enzymes. So in your textbook, two enzymes are given. Which are the two enzymes? Just read. Underline, children, take a pencil, underline those two lines.
lipases are used in detergent formulations and are helpful in removing oily stains from the laundry. You must have noticed that bottled fruit juices bought from the market are clearer as compared to those made at home. This
Yes.
is
So if you buy fruity or any other juice from the market, the bottle is very clear. The same mango, if you prepare juice from the mango, that is not so clear. Is it not? Why? Because for storage purpose, commercially, when these fruit juices are produced, they use certain enzymes, okay, and even with the laundry in our detergent also, which is the enzyme used, it is the lipase, okay. So lipase is used in detergent so that it removes the oily dirt, okay. Yeah, we know lipase is used to digest the fat that we have studied in class 10 and 11, okay. So the oily dirts will be digested by using lipases, okay. So this enzyme is being added to the what is that detergents, okay. Similarly, the next enzyme is the pectinases and proteases. This is added to the bottle juices so that it is very clear. Wait.
This is because the bottle juices are clarified by the uses of pectinases and proteases.
Yes, stop. Which are the two enzymes used to clarify the bottle juice? Gayatri.
Pectinases and proteases.
Good. Pectinases and proteases. What about lipases?
It is used in detergent formulations.
Yes, used in detergent formulation. Okay. So one more. What is that? Enzyme is there. With that, I'll stop and give you a break. Okay. Yes. Gayatri, continue.
Streptokinase produced by bacterium Streptococcus and modified by genetic engineering is used as a clot buster for removing clots from the blood vessels of patients who have undergone myocardial infarction leading to heart attack.
So the next enzyme is the streptokinase. Okay, so streptokinase, you know all the enzyme names end with ase, ASE, lipase, protease, amylase. Okay, so streptokinase, ASC, it is an enzyme and that is produced from Streptococcus bacterium. Okay, and why this streptokinase is used, or how it is used? It is used as a clot buster. What do you mean by clot buster? Remove clot from where? From the blood vessels, okay, of patients who have undergone myocardial infarction. So that is heart attacks. Okay, when a person gets heart attack because of the block, okay, this is injected so that the clot is removed from the blood vessel. Okay, so streptokinase is a very important enzyme that is produced from streptococcus and it is used as a clot buster agent. What do you mean by clot buster agent? It removes the clot from the blood vessels of patients of heart attack. Is that clear? Yes, children? Is it clear?
Yes, ma'am.
Yes.
Yes, ma'am.
10 minutes you have break. It's 11:05 now. Just come back at 11:15 and we'll just continue. S for polar wave joint. Yes, children. Yes, Parthiv and Jessica. Yes, yes. All are there. Anyone absent? This is how many. Oh, so Alvita.
Yes, ma'am.
Read the next paragraph.
Uh, which one? Ma'am?
Under chemicals, enzymes, and bioactive molecules.
Yeah. Another bioactive molecule, cladribine A, that is used as an immunosuppressive agent in organ transplant patients, is produced by fungus Trichoderma polysporum.
Wait. Okay. Any idea what is a bioactive molecule? Anybody? Underline the term bioactive molecule. What is a bio from the word bio itself, you know? Where the biological agent or any microbes is being used. Okay. So underline the term bioactive molecule and write down what is that. Okay. Page number 183. Heading also you have bioactive molecule. We can write there or here. Okay, right? The molecules which are produced. The molecules which are produced as a result of the molecules which are produced as a result of microbial activities. The molecules which are produced as a result of microbial activities are known as bioactive molecules. The molecules which are produced as a result of microbial activities are known as bioactive molecules. Example, all the example you can write. Underline lipases, proteases, streptokinase. Okay? Any example you can write. And another example given is cyclosporin A. Underline the last paragraph under chemical enzymes and bioactive molecules. Cyclosporin A. This is a repeated board question. Like earlier, we have 3 sets of question paper. No, in one set, if asked and asked means other set this will be there. Okay, so you should repeat a question. So write cyclosporin A or underline cyclosporin A. Okay, this is used as an immunosuppressive agent. What do you mean by immunosuppressive agent? This is a drug which is given to the organ transplanted patients, like kidney transplantation, liver transplantation. Okay. So, what do you mean by transplantation? That is, we are getting the particular organ from a donor, which is not our own. Is it not? So, when we receive any organ from other person, though we just do all the tests like blood group matching, tissue matching, everything is done, our body will have a tendency to reject it. Okay. In order to keep the organ intact into the recipient's body, immunosuppressive drugs will be given. That drug has to be taken by the patient throughout his life. Okay. Just to reject the graft. Okay. Just to prevent the rejection of graft, the person has to take this medicine. That means we are giving the medicine just to kill our own immune cells. Okay, so that our immune cell does not recognize that as a foreign agent, so that the graft is not rejected. Okay, not good only, but no way. In order to save the life of the patient, we have to give this one. That is given immunosuppressive agent. Okay, and this is produced by which microbe? It is a fungus, underlying fungus. Name of the microbe is Trichoderma polysporum. Underline Trichoderma polysporum. So when you get this question, the points which you have to write is the fungus you have to write. You write the name Trichoderma polysporum, and cyclosporin A is the bioactive molecule, and to whom it's given, that the point also you have to write. Though they didn't ask also, you have to write. Then maybe full mark you get it. Okay. It is an immunosuppressive agent. That means it suppresses one's own immune system so that the donated or the received organ, the graft, what we call, will remain in the patient's body. It won't get rejected. Okay. So in organ transplant patients. So these are the points you have to write, which is the name of the bioactive molecule, cyclosporin A. And from which microbe it is produced? Fungus. Name of the microbe is Trichoderma polysporum. To whom it is given? It is given to the organ transplanted patients. For what purpose? It acts as an immunosuppressive agent, so it prevents graft rejection. Is it clear, Niranjana?
Yes, ma'am.
Which is the molecule, bioactive molecule?
Cyclosporin A.
Which is the microbe? Name of the microbe?
Fungus.
What's the name? Name of
Trichoderma polysporum.
it is given to which patient?
Organ transplant patients
It is given
for immunosuppression.
suppressive agent. Good. Okay. So Amil, I'm just calling you right from the beginning of the class, but no response.
Yes, ma'am.
Are you there?
Yes, ma'am. I had sent you a message. Then and there, I had told that my mic wasn't.
Okay, fine. Now it's okay now? Jolanta?
Yes, ma'am.
Just tell me the one bioactive molecule, cyclosporin A, about cyclosporin A.
Miss, it is used in immunosuppressive agent in organ transplant patients.
It is produced from by?
It is produced by the fungus Trichoderma polysporum.
Okay, good. Next, Prithvika.
Yes, ma'am.
Read the next one. Next bioactive molecule.
Statins produced by the yeast Monascus purpureus has been commercialized as blood cholesterol lowering agent. It acts by competitively inhibiting the enzyme responsible for synthesis of cholesterol.
Okay, Anaka. Anaka, not there?
Yes, ma'am.
Yes. What's the second bioactive molecule? Which is the second one given there?
Streptokinase.
No. Streptokinase is over. After that, we have seen another bioactive molecule,
Cyclosporin A.
That is over. Next one.
Next is Monascus. No.
Where she stopped?
Ma'am, after cyclosporin A.
Trichoderma polysporum, which is that name given there after trichoderma polysporum?
Statins.
Statin. Okay, underline statin. That is another bioactive molecule. Lipases, proteases, pectinases, streptokinase, everything is a bioactive molecule only. Okay. So cyclosporin A is over. Next one is statin. Okay, Anaka. Statin is produced by which microbe?
Yeast.
Yeast. What's the name of the yeast?
Monascus
Yes, Monascus purpureus. Underline is Monascus purpureus. Okay. And what's the use of this, Anaka?
It acts by competitively inhibiting the enzyme responsible for synthesis of cholesterol.
Blood cholesterol lowering agent.
Lowering agents.
Okay, why it is used to reduce the cholesterol. Okay, see, you know, there are different types of cholesterol. LDL is there, HDL is there. Okay, high density lipid, HDL is good for health, whereas LDL is bad. Okay, so whether you eat the cholesterol containing foods or not, naturally our body synthesizes certain amount of cholesterol. Okay, so when our body has more amount of cholesterol, this can be used. Okay, because this acts as a statin, which acts as a blood cholesterol lowering agent. So how it acts as a blood cholesterol lowering agent? Krishna Priya, what's the next sentence given there?
It acts by completely inhibiting the enzyme responsible for
Yes,
synthesis
so
of
that is the enzymes responsible for the production of cholesterol. So what does the statin will do? It go and binds with that enzyme. So that enzyme cannot produce cholesterol. So underline that word also, it's very important. It acts by completely inhibiting and stopping whom the enzyme which is responsible for synthesis of cholesterol. Okay, Aisha. Aisha? Aisha is not in. Aisha Rakta?
Yes, ma'am.
Which are the organic acids produced by using the microbes?
Ma'am, Aspergillus niger.
Aspergillus niger produces which acid?
Citric acid.
Next?
Acetobacter aceti.
Produces?
Acetic acid.
Okay. Arya P? Arya P?
Yes, ma'am.
Next to organic acids. Aisha told me 2 acids. Next to 2.
Ma'am, lactobacillus
Produce.
produce lactic acid and Clostridium butylicum, it produces butyric acid.
Okay, in this, which is the fungus? Out of this 4?
Aspergillus
Right. All others are
bacteria.
bacteria. Okay. Children, is the board shared?
Yes, ma'am.
Now take your notebook. Everyone take your notebook. Write today's date. And write from this. Write the heading, microbes in industrial products. I'll just give you 5 minutes. Copy down. Microbes in industrial products. Hope all are writing. Harinandan,
Yes, ma'am.
just turn on the camera.
Okay.
Adi. Now it's clear? Nita?
Yes, ma'am.
Aniranjan, are you writing?
Yes, ma'am.
Yes, but I can't see it. Yes, yes. Just show your notebook. You got the notes?
Now I am not writing in my notebook. I will
What's that?
take it to here. I am not in my home right now.
Not in your home.
Yes, ma'am. I will return to my home.
But by next class, I want all the notes. Ask your friends to send it. Hardly 2 pages note, right? And send it to me personally in my WhatsApp. Clear?
Okay, ma'am.
Yes. Hope all are writing quickly. Adit Jaydev,
Yes, miss.
writing?
Yeah.
Okay. Risha. Risha Anil Kumar.
Yes, ma'am.
Writing?
Yes, ma'am.
What about Mohammed Ismail? Anjana J.
Yes, ma'am, writing.
Amir.
Ma'am.
Yeah, writing Amir?
Yes, ma'am.
Good. So hope everybody is writing. Once this is over, just tell me so that I can just scroll it. Children, you'll be asked to submit the notebooks. Okay? So not only bio, all the subjects, make sure that you write and be up to date. Ria, are you writing Ria? Ria Sebastian?
Yes, miss.
Oh, okay. And learn daily portions. Finish this. Everyone finish writing?
Ma'am.
No, ma'am.
At least first 3 lines?
Yes, ma'am.
One second. Okay, those are finished writing. Next heading, you write chemicals and just write, look into your text.
Can you share the previous page for just a second?
No, I'm just telling. I'm just showing to others. Okay, I'll just wait for 2 minutes. Those who are completed this heading, microbes are also used for production of chemicals, enzymes, and other bioactive molecules. Next heading, you write the heading as chemicals and write the name of the microbe and the acids. Okay, in bracket, you have write whether it is fungus or bacteria, everything.
Okay, ma'am.
All everyone finished now? Can I just move? Scroll up. Anyone still writing? Just tell children so that I can write. Can just go in. Can you see the things which I wrote it on the board? Yes?
No, ma'am.
I wrote organic acid. Not visible?
No, ma'am.
No, ma'am.
Okay. Then. See chemicals and organic acid given. Heading already chemicals is given, no? Correspondingly, write organic acid also. What is that means? Okay, see.
Ma'am, can you scroll up a bit?
Right?
Okay.
Okay.
Yes, ma'am.
For myocardial infarction, R is now missing in your textbook. It's a printing error. I don't know in the new textbook whether it is rectified. See that spelling from the board and write it. Myocardial infarction. In old, I think in new textbook it's okay, but in old textbook there was an error. I think now new textbook it's correct condition. Chemicals over. Finish writing? Chemicals? Anyone please respond?
Yes, ma'am.
Oh, okay. Next slide is heading enzymes. And when you write the bioactive molecules heading, there you write the definition which I told you just now. Then write the streptokinase, cyclosporine, and all. Okay. So don't forget to write the definition for bioactive molecules. Notes also. Everyone, you have to write it. And once you complete, I will randomly call you to read out the notes. So don't simply sit and think that you can get it from your friends later and complete the notes. No. Now I will call you randomly and you have to read the notes. So quickly write down. I'll repeat the bioactive molecules definition. Those who didn't write. Okay, if I write it on this, I hope you can't see it. No? It's a problem. Okay. For bioactive molecules, write the definition as the molecules which are produced, as a result of microbial activities. The molecules which are produced as a result of microbial activities are known as bioactive molecules. The molecules which are produced as a result of microbial activities are known as bioactive molecules. Example, any example you can write. So we are using a product produced by a biological agent, a microbe, and that product is used in another biological agent for some treatment purpose like that. Okay, so it is a bioactive molecule, and that could be in the form of enzyme, any chemical compound, or organic acid, anything it could be. Hope everybody finished till enzymes. Yes. Children, are you there? Only one or two always respond. Right, bioactive molecules definition. Hope Rohit and Vinayak, it's clear now. bioactive molecules definition.
Yes, ma'am.
Write quickly, children. If you have completed, just put it in the chat box. Completed. Let me see how many have completed. Quickly. Still starting, you write it. Micros and sewage treatment. Next topic we'll see in the next class. So next class will be dealing with two topics: sewage treatment as well as production of biogas. Okay. After that, one more class: biofertilizers and biological agents. With that, the chapter will be over. Only 5 of the set S is completed. What about the others? Yes, now it's 10, 12 members. Remaining children, they are 50 plus. Still anyone writing, children?
Yes, ma'am. 1 second.
Okay. Write neatly. Take a pencil and underline all the headings, side headings. If you have any different color pencil, you can use sketch also, but do it very neatly. You don't make your notebook tidy. Okay, you can underline the name of the microbe in one color. Okay, you can highlight it. Some color pencils or different color pen will do. Okay, don't make it too much. If you don't know how to use color, then maybe just take a pencil, underline all the microbes name and function. Okay, so that it will be easy for you for studying. All the microbe name with the full spelling, and when you write the generic name and the species name, you should follow the rule. First the alphabet should be capital and all other it's followed with a small letter. Okay. I'll just give you 2 more minutes for completing notes. Okay. Then I'll call you to read out the notes. So that will be a revision also. Okay, so next class we have to learn up till here, page number 183, and we will be having a test. The test is directly from the class. It's an oral test. Okay, where you on the camera and will be giving me all the answers. Okay, I'll mark how many of you have responded. All the markings will be here. Okay, so you have to learn next up. What about Aaron, Harinandan, Mohammed Ismail, Amil, Levin? Not completed. I can see your name here in the message chat box. Only I think 10 to 15 students have completed. What about the remaining ones? Taking this much time? Also, children. Yes, Ismail, 1 minute I'll give you. Yes, Aditya. Others also quickly. Yes, Vinayak, over. What about the remaining girls? There's only few boys in the class. No? So I could easily find out. The boys. Any girls are there? Atul Bini, Krishna. Okay, I think most of you have completed. Yes? Is anyone still writing? Only those persons just unmute and tell me, yes, ma'am, I'm writing. So that I'll stop this one. I'll stop sharing. Is anyone still writing? Can I stop this? Sharing this? Okay. So I don't think still someone is writing. So I'm going to stop this. Okay. So who will I call to read out the notes? Atul Bini.
Yes, ma'am.
Read the notes which you wrote just now.
Only written till bioactive molecules.
Louder.
Bioactive molecules.
You didn't write?
Ma'am, I just wrote till bioactive molecules.
So you want to write that?
Till the second line I wrote.
Which one? Statin you finished?
I finished streptokinase produced by that thing, and I have started cyclosporin A.
So take your textbook page number 183 and write those 2 lines. Same thing only. Okay? Cyclosporin A and statin also you have to write it. The full paragraph, 2 different points you have to write it. Here?
Okay.
What about Devagana finished writing?
Yes, ma'am.
Tejas?
Yes, ma'am.
Can you read from a bioactive molecule that last part? So Atul also be here and you get marks. From streptokinase, can you read? Which you wrote it in your notebook.
Yes, ma'am.
Quickly. Why is a delay? Can you turn on the camera? Yes, read.
Staphylococcus produced by bacterium Streptococcus used as clot buster for removing clots from the blood vessels of patient during myocardial infarction leading to heart attack. Then cyclosporin A produced by the fungus Trichoderma polysporum, and they are used as an immunosuppressive agent in organ transplant patients. Then statins produced by yeast Monascus purpureus use a blood cholesterol lowering agent. It acts by completely inhibiting the enzyme responsible for synthesis of cholesterol.
Okay. So others also, please complete your notes. Okay, don't leave gaps. And next week I will be asking you to submit the notes. Okay, the full notes either through the Google Classroom or in WhatsApp, whatever it is. Okay. Till now, whom I didn't call? Is there anyone whom I didn't call till now? Everybody I called? Is there anyone whose name I didn't call? Everybody I called up? Okay. If
Yes, ma'am.
what's the role of yeast in the production of acids? This yeast is used to produce any organic acids.
It is used for the commercial production of ethanol.
Ethanol, yes. Anaka,
Yes, ma'am.
what is the use of lipases? It is used in detergents, no? What is the use?
It is used in detergent formulations and helpful in removing oily stains from laundry.
Yes. Okay. Risham. Risham. Anjana, yes.
Yes, ma'am.
What's the role of proteinases and pectinases?
The bottle juices are clarified.
It clarifies the bottle juices. Okay. So under chemicals, you need to learn different acids: citric acid, acetic acid, butyric acid, lactic acid. Okay, and ethanol. Okay. So in this, ethanol is used by the same Saccharomyces, produced by the same Saccharomyces cerevisiae. Okay. And only Aspergillus niger, that is which produces citric acid, so only fungus, all other things are bacterium. Okay. And coming to enzymes, 3 enzymes you have to learn. One is the lipase for removing the oily dirt, that is from the used in the detergents. Another one is the pectinases and proteases. It is used to clear the bottle juices. Okay, and another one is the streptokinase, which is produced from streptococcus and is used as a clot bustering agent. That means to remove the clot from the blood vessel. Okay, apart from this, another bioactive molecules are there. These are enzymes. Okay, another bioactive molecules are one is cyclosporin A. Underline that everyone. Page number 183. It acts as an immunosuppressive agent in organ transplant patients. Okay, and that is produced by a fungus, Trichoderma polysporum. The next one is the statin, that is produced by the yeast Monascus purpurus. Okay, and it acts as a blood cholesterol lowering agent. How it helps to lower the cholesterol? This enzyme, or not enzyme, this bioactive molecule, statin, will combine with the enzyme and it inhibit the enzyme which is responsible for the production of cholesterol. Okay, that's why it's given. It acts by competitively inhibiting the enzyme responsible for synthesis of cholesterol. Okay, so till now we have seen how microbes are used in household products and also how it is employed in the production of industrial products. Okay, first one is fermented beverages, second one is the antibiotic, third one is the organic acid, some chemicals, some enzymes, and bioactive molecules. So what are bioactive molecules? Those molecules where we employ or use microbes. Okay, and that product is used in other bio agents. Is it clear? So complete the notes, learn till this and prepare for the next class. Clear? Today who is ready with the prayer? Alvita? Yes, everyone join your hands.
O God, the source of all wisdom and knowledge, grant that I may remember what I have learned and recall it when necessary. I offer thee my work and my endeavors, my failures and my success. Forgive my faults and give me